Welcome back. Today we're going to be looking at PyTorch in Python, and unfortunately I won't be able to make you an expert in PyTorch in just a single video, but hopefully you'll learn some of the basics, some of the features it has, and you'll be able to go away and do your own research and create your own project based on what you learn if you're interested in it, and if you're not, then you can just do other stuff. So PyTorch, it is a Python package and it has these two features. And the first one is tensor computation. So this is the ability to do maths on high-dimensional equivalents of matrices. And it also has GPU acceleration, so things can happen very quickly. The other one is this neural networks based on this tape-based system, which is slightly different to other ways of doing automatic differentiation, but that's a very useful thing that it provides. PyTorch also has a lot of sub-libraries. So the first one is Torch, which is like NumPy, and it does this tensor maths and tensor operations. Then you've got Autograd, which is their automatic differentiation system. Then you've got JIT, which is used to compile things that can be run on your GPU. Torch.nn, which allows you to have neural network modules and they're integrated with their Autograd system so that you can do backpropagation and gradient descent, among other things. Multiprocessing, which allows you to do machine learning on multiple machines, so you don't just have to have one GPU, for example, you could have several and distribute them using the multiprocessing. And then the utils, which has a bunch of utility functions. So the way to install PyTorch depends quite a lot on your operating system. So I would recommend going to the PyTorch page and installing it from there. And usually you can do it with pip, but that's not always the case, especially if you want GPU support. So the first thing we need to do is import Torch and all these related libraries. So we're using Torch Vision datasets because the dataset we're going to use. And then we've got matplotlib and NumPy as kind of utilities. And this is the magic line which makes everything print in the right place. And then we're just resizing everything so that it's the right shape. Next, we're going to get some data and we're going to download the Nist Dataset, which is very famous and I've never used before, but is very common for introductory tutorials, so I thought, why not? And it's going to be saved in the data directory. We've got the train and the test part of our dataset. And the classes here are just a list of the numbers from 0 to 9 because they are handwritten digits. And if we want to view the data, you can see it's not very easy to see exactly what's there, but fortunately we can just display it with matplotlib. And so we pick 5 random digits and they happen to be an 8, a 2, a 3, a 7 and a 1. And you can see they've got these labels. And technically, we don't need the classes because it's going to return an integer anyway with the right number. But if we just put a string here, then that's a bit nicer. And if you had different class names, then you could do that. So now we're going to wrap everything in a data loader. And the data loader is very useful because it can preload things by running in the background. It puts stuff in batches, it puts stuff in a tensor rather than in just a NumPy array or another kind of data format. And you can see that our data is in batches of size 64, and each image is one channel saying it's black and white, and then 28 by 28. And the size of the labels is 64, because it's just a list of 64 numbers. So now we're going to create our module. And we just need to define two things: the network itself. So we've got this convolutional part, which kind of slides a window over each part of the image and does some calculations. And then this maxpool2d, which then looks at the maximum of these convolutions. And then we have the flattening bit where we turn our image into a single list, and then here we perform 2 linear layers where we classify everything into the correct label. And you can see that when we pass it forwards, we just do those layers in order and we return logits because they're not probabilities yet. We also set up CUDA because I have CUDA available, otherwise it will run on your CPU, and it should tell us that we are using CUDA. And here I just put the model onto my GPU, so it's now sitting there and can run whenever I pass things through it. To actually use our model and train it, we need a loss function, so we're using cross-entropy loss and an optimizer. And I'm using Adam, which is fairly common, and I'm using all the default settings, but I've passed the model parameters because they're the things we're trying to optimize. Now our training loop. So we loop through all the batches, and we have an X and a Y, and we put them both on the GPU because you need to put everything on the same device as the model to pass it through the model. Then we calculate predictions, calculate our loss, we backward propagate anything, and then we say here that every 100 batches we're going to print the loss, the current, which is how far through we are, and show our progress. Then when we test it, we're also going to calculate the test loss, but we're also going to calculate our accuracy, which is the number where the column we've predicted, so the digit, is the same as the actual column, and then we just cast it and calculate their sums, and then we divide by the number of batches for our loss and the number of items to get our accuracy. Then in each epoch we're just going to train it and then test it, and at the end print done. And because of all these parameters, it's quite a small model, we only need 2 epochs really to get everything working. So we can then just let it run, and usually you wouldn't watch a model run, you just leave it for a few hours, but because it's only going to take a few seconds, we can just watch it and see as the loss decreases. And you can see we've done pretty well, we've got 97% accuracy. The loss has been decreasing. Another thing that's often important to do is save your model. For us it's not that necessary because we're never going to use this model again, but it does mean once you've trained your model, put all that computational power into training it, you can then use it somewhere else rather than deleting it at the end of your session, which isn't great. And then we can just load it back again. And this is a way that means we have to have the model defined when we load it, but there are other ways of doing it, so you don't have to do that. Now we're going to evaluate our model, and what we'll do is we'll take 5 different things in our test data set and just make predictions and see what the model says. And to make a couple of things clearer, here we're just displaying the image. Here we're making sure that we have that extra dimension, because you remember initially there were 64 in batch sizes, but now we're just doing batches of 1. And then here we make predictions and we get what it actually is, and then just add that as the title. And so you can see here we have a 1, which we got correct, an 8, which we got correct, an 8, which we got correct, a 2, which we got correct, and what looks like an 8, which we predicted correctly. So you can see that has been hugely successful. We've managed to go through MNIST, which is quite a large data set, and generate some pretty good predictions using PyTorch, and nothing too sophisticated on top of it. If you want a challenge, you could try rerunning this, tweaking parameters, seeing if you can get a higher percentage, but anything really over 95 is good enough for this dataset because it's not perfect and there are lots of things that you might disagree with in the test dataset. So hopefully you've enjoyed this video, learn the basics of PyTorch, and hopefully have a flavour of what it's capable of, so that if you ever need to do machine learning in the future and you think PyTorch is the best way of doing it, then you can just go ahead and look at the documentation, look at some of the tutorials, and you know roughly what you're going to be able to do. So hopefully you've enjoyed this video, seen some cool stuff, and I'll see you again same time next week. Till then.